All right, let's see if we can do this here. So what can you plug in here for a domain value? Well, you still can't plug in negatives, but you can plug in 0. So here comes my table. Plug in 0, the square root of 0 is 0. 0 minus 2 is -2. So we're going to graph that in a minute. Can you plug in 1? Certainly. Square root of 1 is 1. 1 minus 2 is -1. I have no idea why that says -2. That's silly. That should say -1. Maybe I plotted it correctly. Let's check me in a minute. Plug in 2 here. Nah, 2, you could plug in 2, but it's messy. It's decimals. Plug in 3. No, thank you. Decimals. Plug in 4. We like that one. Square root of 4 is 2. 2 minus 2 is 0. Good, I got that one right. And like I said before, this is probably just written wrong here. I'm sure I plotted it right. I hope I plotted it right. What's the next good integer to plug in here? Not 5, not 6, not 7, not 8. 9 would work. The square root of 9 is 3. 3 minus 2 is 1. So now we have 1, 2, 3, 4 points. That's plenty of points to graph this thing. You know, we could keep going to 16. Square root of 16 is 4. 4 minus 2 is 2, but we don't need that. It wouldn't even fit over here on the graph. So you could probably plot all these positives. They're all in the first quadrant. Where is 0, -2? It's down 2. Now you might recognize this. This is essentially like mx plus b. This is like the plus b. This is like the plus b. The mx is a little funky because there's not really a number in front of here. There's a square root in front of x. So that's what sort of affects that slope thing. But the b is still kind of the same thing. The y-intercept is affected by that number there. Affected by that. That's not the y-intercept, but it is affected by that. Write 1 down 2. Write 1 down 2. Which hopefully I did it right. Should be write 1 down 1. Yes, I did. So wrote it wrong, plotted it correctly. 4, 0. 4. Stay right there. Write 9 up 1. I'm way out here. And you'll see that's the exact same graph as we had a little while ago for the original rad x, but this -2 has moved the graph. It's moved it downwards. It shifted the graph. Every point was moved down 2, down 2, down 2, down 2 from that original. And if I didn't have this -2 here, it's essentially, now it's shifted downwards. And of course you can figure out what this is going to do. This is going to take every y value that I would have gotten if this wasn't here and make it 5 taller. It's going to move the graph up 5. Should make perfect sense on there. So you don't have to, now, once you kind of see these patterns, we want you to sort of draw some conclusions and predict some values here. If you subtract a value outside the radical, it's going to shift things down. If you add a value outside the radical, it's going to shift things up. So this curve would be the same as the original curve, but every y value is 5 more. So instead of starting at 0, 0, this one would start at 0, 5. You could plug in 1 here. Square root of 1 is 1. 1 plus 5 is 6. So it started at 5, 0, 5, and then it would go to 6, 1. Sorry, 1, 6. 1, 2, 3, 4, 5, 6, 7. And that would be at 4, 7. Because the square root of 4 is 2. 2 plus 5 is 7. Hopefully that makes sense. It would look something like this. Off the graph a little bit over here. So what we're really getting you to sort of wrap your mind around is adding and subtracting shifts the graph up, down, or left and right. Just depends on where you add or subtract. Outside the radical, or like it did previously, inside the radical. That's the big picture. And of course it changes the domain and the range. Here the range was 5 taller than it would have been before. Here the range is 2 smaller than it would have usually been. All right, so this next one I've got sort of a double whammy. I've got a plus inside the radical and a plus outside the radical. See if you can graph it and come up with a domain and range based on your graph. It's going to be good.